next speaker who has already agreed is Vincent from Mangrove. And I'm not speaking French, but sorry, I will speak in English. So Mangrove, what is Mangrove? Mangrove is first, it is based on DAO principles, as I'm not mistaken. So it's unlocked liquidity, DEX, and strategies. The main difference between Mangrove and other DEXs is the ability to attach quote to offers, and this translates into several disruptive mechanisms. Collective liquidity. The liquidity on offer on Mangrove is not locked on a pool. Since an offer contains code, defensive mechanisms can be baked into against the promise previously made. In persistence for the executed code, the offer can automatically repost itself on the order book. Let me thank Vincent assistance again. She helped a lot in delivering info about Meetup to community, to organizing and arranging Vincent's joining. So Vincent, if you are ready, so feel free to turn on your mic, turn on your camera, and we are extremely waiting for your wisdom here on our Meetup.
Yeah, I'm ready. I think this is me. Hello, everyone. Yes. So, well, maybe I'll just repeat what you said, but maybe slower. So, Mangrove is a large contract that allows one to define specific markets. So right now we have 4 running on Blast. By the way, we're thinking, we don't know quite exactly how to do it, but of turning permissionless so that people could open their own markets, just like Uniswap went permissionless, I think, May 2022. I think it's a great way to increase the number of markets. So it's a market making machines. Every market is an order book. So just in a few words, an order book is a data structure where people express their willingness to trade. They say, I'd like to buy that much of this thing at the maximum price of this thing, or I'd like to sell that much of that thing at the minimum price of that price. And that's called an offer, or sometimes also a resting order. This is the dominant way of trading in usual finance. Not so much in decentralized finance because of all sorts of reasons. It's a data structure that's costly to maintain, and people use it in a way in traditional finance that doesn't seem to be meshing well with the latency of blocks in decentralized finance. And Mangrove is kind of the answer to this. We're trying to reconcile the reason why it's the dominant model in centralized finance and with the specific abilities and restrictions of running the market on a chain. So I think on the one hand, we're opening a completely new design space for liquidity provision. If you look at decentralized finance right now, you have a choice of a bunch of AMMs, or you can participate to batch auctions off-chain. For example, Vertex came to Blast a few weeks ago. And if you look at how they proceed, every 10 blocks or so, they post a massive transaction of 20 million gas. And that's kind of the summary of everything that happened on their offside exchange place, which they now settle on the L2, later to be settled on the L1. So just to be clear, our design is not like that. We are continuously on chain. And if you shoot transactions to our markets, they'll be inserted in the next block, not in 10 blocks. So that's one difference. So the one thing you can do, one thing you have to do to begin with, if you want to offer liquidity on one of those markets, is you have to specify not just as usual how much you want to sell or buy and at what price, but you also have to tell the engine how much gas you request to execute, and given the address of a contract that will be managing the offer in case it's matched by the engine. So the sequence goes like this. There's a market order that wants to consume liquidity. Let's say it wants to buy some WEEF. And at some point, the engine matches that order against your offer. And what it does, it will call the contract that's sitting at the address that you provided, and it will wait for that code to return with the promised liquidity. And importantly, it will give to the code control on the money of the taker, the money of whoever wants to buy, in my example. So now that piece of code is running on chain. It's a contract. It may manage many of us. In general, it will manage many of us, possibly on multiple markets. And what the very first natural step, which is what you referred to by defensive, is to look at whether the price at which it's trying to sell right now, which may date a few blocks back, is actually still a proper price. So there are various ways to do this. You can ask other DEXs what's the current price. You can ask an oracle, obviously. You can ask your own private internal structures. And then typically, I'm not describing any, it's free form, right? I mean, you code absolutely whatever you want. That's the beauty of it. I'm just describing a reasonable way things proceed as in the strategies that are currently deployed on the books. And then if it decides to trade, it will try to deliver the whatever liquidity it promised. Let's say 1 ETH, 10 ETH. So at that stage, it can do everything you want it to do. It's just a piece of code. One particularly amusing way to solve the offer is to go and buy that liquidity by buying it on another DEX with the money of the taker. So that's what we call forwarding. It's also called redirecting or mirroring liquidity. And since you have a choice between the 5 other DEXs on chain that are currently on the same pair, you can take the cheapest one at any time with no latency, and then you pick it up. And in effect, you have some kind of rudimentary on-chain aggregator mechanism. But you can do it in other ways. You can, for example, another contract we have developed will actually redeem an LP position on another DEX, partly, to realize enough liquidity to deliver. Another way to do it is to go to a lender to withdraw or even borrow on the fly on a lender. So we also have that type of code available. And eventually, delivery will happen. The engine will go like, okay, it's like a flash loan. Okay, you said you were going to deliver that much. You actually did deliver that much. So all is good. We're not going to revert that. And if the taker's order is still not fulfilled, the engine will go to the next best offer and so on, as an ascending option, which it is. Other books are called continuous double options also sometimes in the literature. So this is that design space, meaning you can attach any code you want. You can be creative. You can have hybrid strategies. You can, let's look at a few examples. You can, for example, if you're in the game of having looped positions on lenders to increase your APY, you can de-loop and re-loop on the fly. All the liquidity that you can access on chain within the same transaction, again, like a flash loan, is available for your contract to pick. So in a way, the chain is your backend, your back office. Wherever you control liquidity or can buy liquidity in another, you can do it. So I'll stop there just for a sec. And we have deployed on Polygon months ago before we came to Blast, at the time Blast was launched. And at the time we had people were already programming those forwarding contracts. And a few weeks after the launch of Blast, they came. We're happy to see them coming in. And we've had tremendous success, very large volumes out of a very, very tiny amount of capital. You do need a bit of capital because you need to, for technical reasons, you have to build a provision for your strategy, and you still need a bit, but orders of magnitude less than what you would need if you were an ordinary AMM that locks provisions into a contract. So let me return to, this is how Mangrove looks like to someone who is a dev. Like, so the typical person this kind of presentation talks to or speaks to is a person who's someone considering, for example, developing hooks for Uniswap version 4, because that's exactly what it is. These are hooks. There are strong differences between what we have and what Uniswap version 4 is meant to be having when it's out, maybe Q4 or Q1 25. But roughly the idea is that every offer on the book is under the management of its own hook, and you program the hook. So having said that, not everyone wants to be exposed to the complexities and technicalities of developing their own liquidity provision methods. So we also have a vault right now. I think it opened a few hours ago, actually, which is a vault in which you can put your money in a completely passive way, and the vault will manage your offers in a way that you are insulated from the complexities of actively managing this kind of position. Next thing I want to say, this is what the word persistent meant in the little blog you read before. The code can be an AMM. Any discrete AMM can be encoded in this way. We have one, it's called Candle, but we could implement a discrete version of Uniswap version 3. Actually, we have there's a large class of AMMs that can be encoded in this way. And the funny thing is that, differently to everything that exists, multiple such AMMs can live on the same pair. It's not like, oh, I have a new AMM, I need to open a new market, which is the Uniswap version 4 concept. It's no. You have a new ID, you come to the existing market, there's just one, and this is where you're going to deploy, and you'll be absorbing the order flow of the market, not of your own market with all the pains and diplomacies and reward programs that you need to put together to get to bootstrap what's at the beginning an empty market, right? So you can write the order flow. You can compete on how good your own AMM and your own liquidity provision methods are. How good is your way to quote liquidity? How good is your way to source liquidity? And we've seen a fair amount of that competition go during the last 3 months. We have seen aggressively providing contracts, liquidity providing contracts. Sorry, contracts providing liquidity in a very aggressive way, meaning very little spread, sometimes negative spread, probably excited by the reward program of Blast. And the conclusion was that at some point we had 80% of the time we had prices that were better, fees included, of course, that were 80% of the time better than on for example, which is a very, very large Uniswap clone that's deployed and a major source of volume on Blast. All right. So now, if you look at that connects to what I wanted to say last, which is that if you're just a taker, if you're there just to consume certain type of assets, which you want to buy or sell, depending, if you're a pure trader, let's say, none of those technicalities are of any concern to you. All what you want is a good price. So we do have really good prices. And now your concern will be more, what's the dApp like? The dApp allows you to deposit in a vault. The dApp allows you to deploy your own instances of that AMM that we've called Candle, which has a, let's not deny it. It's somewhat a bit complex, but you don't want to. If you just want to consume liquidity, it's just another place where you can trade, and we're giving you good prices. And so the dApp had teething problems. It was really hard to get the interface to be responsive. I'm sure all the devs who've deved some front end on blockchain will be sympathetic to our plight. But now we have an SDK which is super optimized, and it's become much snappier. We'll put back we'll put back some of the features we had to take out to redo the SDK, and we'll put them back in. We'll add some more pairs, more stuff. And right now, I think we are reaching the place where prices are good, UX is good, simple liquidity provider that don't want to spend too much of their time providing liquidity have a vault. People are more willing to play clever games, have their own candles, and people who are at the apex of the system, the devs, the Solidity devs can provide liquidity within their own contracts, which was the entire point of Mangrove.
So we have already got a question from our team member, Eugene, who's extremely dev-like guy, just because he's marketing, but he loves tech side. And he has researched Mangrove a lot. But he asks, your concept of strategies is very interesting, but I haven't researched it enough yet. Can I, he asks, create a long-term rebalancing strategy using your protocol? For example, he specifies, if I supply liquidity in ETH to USDB and Blast to USDB pairs, I need to reinvest the received income into the token that is undervalued by the market. I.e., if ETH becomes cheaper relative to Blast, I use the income from the pools to buy back ETF for Blast, and if ETH becomes more expensive, I sell it and accumulate Blast. I hope you have understood the question. What will be the answer?
Yeah, of course. You can. We're not doing this right now. We have exit bots because we also have our own candles that we manage inside. And we since we're like day traders, we've not implemented this on chain, but you can absolutely trigger a swap on a DEX to rebalance your own internal capital on the fly, depending on the information that's available to your contract. You can totally do this. There are multiple ways in which you can do this. You can do traditional on-chain, so that's not traditional, but inventory management. If you think you have too much of something, you can decrease the price at which you're selling it, for example. So you can somehow bias the way you're offering stuff, so to decrease how long you are in a risky asset. You can also borrow the risky asset if you think you have too much of it, instead of actually acquiring it by mirroring, for example. So all the things are possible. You can buy it on the fly to replenish, to rebalance your portfolio. You can move in price space, a bit like I think Maverick was doing this on Arbitrum. You could opt in for some kind of price tracking methodology. By the way, the forwarders are all tracking price constantly. Maybe I should say a word about this because it's new, I think. So although we see the idea already at play in other DeFi projects, the forwarder, independently of the fact that it's sourcing its own liquidity from other DEXs, that's kind of independent, constantly recomputes its positions in price space. constantly, meaning technically, each time it is tapped by the market engine, it will draw information from the context, look at what the current consensus about the price is, and that depends on the sources, of course. So right now, for example, when we look at the traces of the forwarders running on our markets, we see that they look at 5 sources in the transaction. So they have 5 prices. I don't know what they do with it. Maybe they do some kind of average. Maybe they take the smallest. And then that will be the new price, the new origin in price space, and they will redeploy or republish their offers according to this new origin. So each time they're moved, they move in price space. But you don't have to do it each time. You can do it each 10 blocks. You can have a bigger spread. You choose essentially the average frequency at which you update your prices. So you can move in price space, rebalance your candle if you want. If you use specifically candle to provide liquidity, candle is not like Uniswap version free. The 2 sides are independent. You don't have to, if you choose one, end up in an entry price, it doesn't freeze the amount of the other asset that you need to have. So there's more degrees of freedom, but yeah, you can do all that. What's the limit here? I hear you ask. The limit is called the block size. Currently 30 million on Blast. Remember that Vertex consumes 20 million every 10 blocks, right? So it's not like the block size is not used. Some large players actually use a lot. But further than 30, it's not going to get through. Base, for example, is 90 million. And Polygon was 17 when we started and 30 a bit later down the road. So Mangrove is resolutely placing a bet on the fact that block sizes are going to become larger and larger, that gas prices are going to keep low. Right now, they're not low, unfortunately, on Blast, but they are going to keep low, just like they're on Base, for example, on Polygon, where it's 10 times, 50 times cheaper than it is currently on Blast. It used to be very cheap on Blast, which was fantastic. And so if the gas price is low and the block size is large, then you can put any amount of logic in your contract and do crazy, let your capital go through crazy hoops during a transaction. So just to give you an idea, our forwarders request an amount of gas. This is not the amount they are actually consume, but this is the max they are saying they're going to consume, which is 2 million. And that may be a bit too much when the gas is expensive. Maybe we'll set it to 1 million. So this means everyone who has a contract needs to dumb it down a bit. Yeah, there are still things you can do, but you have to optimize for gas. If gas goes down again, then we'll put it back to 2, 3. And with 3 million of gas, there's so much you can compute. You can actually do optimal splitting of offers, which is to say you can do something similar to Paraswap, 1inch, all the off-chain aggregators, but without latency, which is obviously much more efficient and appealing. So no slippage, you just get the best split across different sources. So yeah, good question. You can absolutely do that. Anything that you can code, you can do with the limit of the block size. And okay, maybe some slight additional remark. The gas price is actually not of any concern to the maker because it's the taker paying the execution of the contract of the maker. The maker only pays when he fails to deliver. We didn't talk about this. Maybe it's not the most interesting part, but when the offer is not actually delivering, then there's a compensation taken by the engine and paid to the taker. And the compensation is computed in a way that the amount of refund that the taker gets exceeds by a factor of 2 the current gas price. So if you pay 1 to run my contract and it doesn't work, then I have to give you 2 through the market engine. But other than that, if I deliver as a maker, I don't have to pay gas. It's you, the taker, paying gas. So here, the way to prevent too much of a price distortion by the gas fees, either to be in an environment where gas, L2 gas at least, is negligible in price, which was the case, or to be in an environment where the max amount of gas any given offer can consume is kept below a decent limit.
Well,
there are other ways, but...
Yeah, thank you very much for such a detailed answer on such a serious question. I think we enjoyed a lot of the answer. I wish I would have listened to you forever, your explanation. Extremely, absolutely. I love
Thank
it.
you.
We have one more question from Rostislav. He asks, there is a minimum amount required for limit orders on Mangrove, at least for now. It's circa USD 155. Do you consider the possibility of reducing the limit order amount nominated in USDB?
So it's the perfect segue to what I was saying before. We are one way we can control the amount of gas per offer that the taker has to pay for, in addition to paying for the asset itself, obviously. Is to ask that the ratio between the value of the asset provided and the amount of fees requested, in the worst case, is above a certain factor. Let's say above 100, above 1,000 even. In other words, you don't want to pay more than 1% or 1,000 fees for what you're buying, right? It would be stupid to buy something for $10 and pay $10 fees. So the way we do this is by, it will mechanically lower bound, so fix a minimum size for offers like $150 for a basic limit order is about what we're having right now. If we raise what we call the density, this particular ratio, that minimum size will go higher, but takers will relatively pay lower fees. So when gas price is high, minimum sizes of offers will go up. I mean, it's a tendency, right? These are parameters that we set in the market. But if gas price goes lower, yes, certainly we can take the mean size lower. It's a way to control the difference between net price, so gas fees included, and gross price, which are the prices you read of the book.
Well, it's been extremely useful. I'm totally amazed of your speech. Thank you very much for joining us today, Vincent. And I would additionally thank Agathi for helping arranging your joining us and your delivery of speech and answering your brilliant questions. So Agathi, you are an amazing lady and absolutely devoted. I wish everyone in Web3 would have been like Agathi, so passionate, so amazing. Thank you very much, Vincent.
Thank you, guys.